Ace for K again. How are you? I hope everything is going well. I want to go over subnetting, how to subnet. I already have a blog out. Some of you may know I already have a blog out on subnetting. And it really goes, you can see right here where it is. You can get it to any of my blogs at blogs.msmvps.com/ace4k, and I have a whole mess of blogs there. I must have about 60 or 70 blogs by now. Anyway, this goes about how to subnet, and just to go over, just as I have written here in the blog, there's different tutorials and methods people teaching, instructors and whatnot teaching how to how to subnet. I mean, there's which way is best. I don't know. Everybody learns differently. I'm going to show you one method that I found successful among my students, and it seemed to help. And yeah, there is binary bits involved, and you can't get around that. But see, and that's because subnetting is all about the bits. What you're trying to do is you're trying to control or provide, whatever way you look at it, a number of hosts on a network. And if you don't have a lot of IPs to give out, you can control the number of IPs on a subnet just by changing the number of host bits. And we're going to talk about that in a minute here. So subnetting is the process of dividing up a network ID into more or less IP addresses based on what's needed for your network solution. Everybody's requirements are different. Back in the 90s, public IPs were all over the place. They were a reseller would get a for an ISP, say, could get a whole /24 block. What that means is it would get 254 IP addresses. Did they one for the router, 253 machines. Yeah, you can't use the first one, 0, that identifies the network. And the last one's 250.255 is the broadcast. I'll talk about that again as well. So as IP addresses were running out, they had to come up with a way to stop this wastefulness. I mean, some companies bought up large blocks of IPs, and they're sitting there doing nothing. And anyway, what we're going to do is show you how to do this in the fact that in the view of you being an ISP, and your customer calls you up and say, hey, I need to set up a network, I need to have some IP addresses, and we'll go from there. The best way to start off, and I'm just going to open up a blank notepad here and just go from there, and maybe that'll be the easiest way to do it. And we're going to use this as our worksheet. So you're the ISP. You got a customer called up, say, "Hey, you need a new network. Sure. What would you like? Maybe you're like the Comcast or the Verizons or somebody else out in the world that's going to give you high-speed broadband, whether it's cable, it's Fios, or T1, T3, or whatnot, or DS1, DS3, whichever way you want to refer that as." So you're going to say, hey, I got a small business. It's a small mom and pop shop. I just, run maybe a print shop, and I have a handful of people. Okay, well, tell us a little bit about yourself. Like how many, how many users you're going to have? Well, maybe 15 users. Okay, so this is a small shop, but we have a good payroll going, and we get a lot done. Okay. Do you have a printer? Is there going to be phones connected? Phones, other devices that may need internet access? Sure. Let's say there's going to be maybe 3 people. Actually, you know what? Nowadays, 10. We're going to say 15. We're going to say 10 of these people probably need some kind of network connectivity for their own devices. That's if you're allowing it, of course. We're going to right now say we're not going to allow anybody to connect with their phones and stuff. We're going to just say we're going to stick with production devices, maybe like a couple printers Servers, yeah, of course. We're going to have, how many servers do we have? Well, we have, it's an AD domain, so we're going to have 2 DCs. Why 2 DCs? It's always good to have 2 DCs. 1 DC and have 2 replicas. And don't forget, there is no PDC, BDC thing. Okay, I'm sure you guys already know that. So we're going to have 2. And what else is going to need an IP address? The router, right? The router needs an IP address. That's your gateway, right? Let's get that in there. That's going to need an IP. What else do we have? Anything else in there? Besides the tablets and stuff. We're not going to get into that right now. So what's that equal to? So what's that look like? 15, 16, 17, 18, 19. It's 20, right? Is that 20? Did I add that up right? Close enough. Okay. So 20. So 20 IP addresses is what we're going to need. So we know that we have blocks of IPs in /24 ranges. /24 means that we have 256 addresses, 254, 253 that you can use in a router. But this customer only needs 20. So do we want to give them now that whole block? No, we don't. So what we need to do to find out, to make this work, we need to find out what mask we're going to use to make this these 20 IP addresses, and what will the range be? A range of IPs. I can type here. Okay, what else do we want to find out? So, say in stock we have this range right here. Let's say that's 0. Okay, and that's actually with a /24, or also known as 0. That actually equals 256 addresses IP. But remember, you can't use the 0 and you can't use the 255. So it really comes down to 253 usable, and one of them, plus the gateway. So we don't want to give that out. So the first thing to do to find out how many IPs we're going to need is to find out what the binary equivalent is of 20. Okay, there's a number of ways to do this. Sometimes the easiest way is just to use the calculator. Yeah, you have the calculator. The calculator is available to anyone on your computer. Even when you take an exam, the calculator is available. You can see right now it's set to decimal, so I'm just going to type in 20. I'm going to click on hex, and I'm sorry, binary. That's what I want. I want binary. Excuse me. See the results there? The results are 10100. So what is 20 in binary? It's 10100. See, I really don't care what the number is. I really want to know how many bits there are. So what do we have here? 1, 2, 3, 4, 5 bits. Okay, so that's what I really wanted to know. That's the only reason why I wanted to convert that to binary. I don't care what the number is, 20, 21. I don't care. I just wanted the number of bits. Okay, so the bits equals 5 bits. So that's what I want to do. So the reason why is, like, when I take out, take this, look at this mask here. This mask here actually equals to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's what it really equals to. The reason why is that if you put 255 in the calculator here, under decimal 255, and you hit binary, and this is the only reason why I'm using the calculator, because I can do this quicker than I can, typing it out or writing it out on a whiteboard if I'm teaching it. You can see it's the 8 bits. So that's why you're looking at 255, 55.255.255.0. I'm going to break this down and space this out. The reason why I want to space this out is because it's easier for me to read it. And plus, when I learned binary years ago, I learned hex at the same time. The reason I was working on a mainframe. I was a mainframe operator, and we had to read core dumps. And the core dumps were all in hex. Just like you see a blue screen, it's all in hex. You're actually seeing what's in memory. Same thing with the blue screen. It's not much different when you're looking at the core dump. Mini dump or a full dump. Anyway, we looked at, this is a byte here. We looked at this portion here as the, I'll just copy this out here a second. We looked at this portion as the high order and the low order of the byte, high and low. So we could actually converted this to hex by saying we'll take that copy. We'll look at this. We'll go up to the calculator here, put it in hex, and just click on. Whoops! I want to go to decimal here. Actually, binary. We're in binary. What am I saying? Binary. 1, 2, 3, 4. Right now, if I go to hex, you can see it's F. That's why you saw those Fs earlier. So actually, this is equal to, and I'll just space this out here. FF. So it's really. Actually, the equal FF. Whoops, that's not what I wanted. I hit the control button. That's what I wanted to do. I wanted to hit that. So really, in this case, FF in hex equals 255. Anyway, that said, we'll come back to hex a little later. I'll just get that out of the way. What I want to do is, the way this works here, this portion here, up to this guy right here, I use the caret here, that is the dividing line between the number of hosts and the number of networks. In this case, the ones equal to the number of networks, and the zeros equals to the number of hosts. So right now we have 8 bits for the hosts. That's what it comes down to. All right. Now what does 8 bits equal to? Well, I can put this in binary. I can't put 8 zeros in it. It doesn't want me to do that. So I'm just going to illustrate what that means in 8 zeros. Well, you already know what it means. It means 255. That's what I was going to do, is put and we're going to put 8 ones in here and translate it to decimal. It's 255. So this is actually 255 IPs. Actually, it's 0 through 255, so it's really 256 IPs. And yeah, I keep going back to saying 253 usable. You'll see more in a little bit why that is. So this side is the networks, and this I'm sorry, that's incorrect. This side is networks or hosts, and this side is the nets here. So what we want to do is we want to move this this caret over here. We want to move it in that direction. I'm sorry, in this direction. Why do I want to move it in that direction? I want to move the ones to the right. This way I can get less hosts, because right now the 20 is actually 5 bits. And actually, all I need are these 5 bits right here for the hosts. So that means, remember, hosts are 0, right? Remember, 0 are the hosts, 1s are the networks. So I only need 20 IPs for this customer. So I only really need 5 zeros. That's it. So really, if I look at this whole thing here, copy that, paste it down here, I just need... I'm going to take these away and make ones. So really, now the caret is sitting over here, or the dividing line. That's the dividing line now. So I'm just going to get the spaces out of here a second, just to illustrate it for this last byte here. You see there's 5 bits now for the hosts, and there's 3 bits for the network. Really, if you look at this, if you add this all up here, this is 8, 16, 24, and 3 is 27. So this is actually equal to a /27. That slash number is always a number of network bits. All right, so I know that a full version 4 IP address here is 32-bit. So I can just say to myself real quick, oh, 27/27 minus 32 is 5. So there's 5 bits for the host. So I know right away that it's going to be a smaller network. How small is the network? That's a good question, because remember, we want to see mask. What will the range of IPs be? And also, what I forgot to ask here, number of IPs on the subnet. And here's something else we're going to ask ourselves: is how many subnets can we get out of the mess? Okay, and remember, this is an inventory here that's unused. All right, just divide that out a little bit, and I'm going to save this so I can use it a little later here. I'll just go up to docs here. I'll just go to C drive here. You know what? I love it here. I just didn't want to open up anything else here, but I'll just get back to here. Oh, I already had one out there. Oh. Anyway, let me see. Where are we at? Okay, so what we want to know is, to make this work here, we want to know what the mask is, because right now we know what if we're using all 8 bits here per byte. And I'll just take the spaces out again, just so you can see what we're looking at here. There's 8 bits per octet. This is an octet. There's 4 octets to an IP to a version 4 IP address. That's where you get the 32 bits. Right now, this is 255. This is 255. 255. Well, what's this? It's not .0, right? So we can figure out what it is. I mean, you can see the way the IP is. If we look at, I mean, the way that it is on each octet has 8 bits, right? The farthest left bit is value is actually 128. The next one in is 64, 32, 16, 8, 4, 2, 1. Now there's 1, 2, 3, 4, 5, 6, 7, 8. That's what each bit here is. 1, 2, 3, 4, 5, 6, 7, 8. If you added up these right here, this will actually give you what this is, what this last part of the mask is here. It's actually 224. If you're not sure my addition was correct, I could just put this into the calculator, and I'll put that to decimal. Actually, it's word binary. I can just do a paste, and that's what's nice about the calculator. You can do that and just go to decimal. You can see it's 224. All right, so now we have our mask. 255.255.255.224. This is so that's our mask there. So that's what we're actually going to do, and we're going to just put that in there. All right. So that's our mask. That's what we're going to be. That's what we would use to configure the network card with the IP addresses. Okay, what IP addresses we're going to use? That's the bigger question here, right? Well, that's one of the questions. Everything's important. There's 5 bits here. Remember where we left off here? And I'll just copy this out here again. And I'll come down here. I'll just take this out of here. Cut that. Put that here just to get it out of the way. This is right here. This guy, that's what we call the delta. The delta is the first significant bit to the left of the zeros of a mask. What is the delta? Well, let's take a look at what it is. It's the we have 1, 2, 3, 4, 5. The first bit after that, the delta, is the magic number that we're going to use to figure out what our ranges are. So if this 0 were to be 1, this second one is 2, the third one is 4, the fourth one is 8, the fifth one is 16. Our delta here is 32. Now, if this was a whiteboard, I would be writing that as the delta, as the Greek delta. Looks like somewhat like a triangle. But in this case, I'm just going to type out delta equals 32 because it's the first one to the left of the zeros in the mask. Okay, which in our case is the sixth position from the from the right. All right. So what do we have now with 32? Okay. Basically, 0 starts the first range. Always 0. The second range is, in our case, a delta is 32. We just keep adding the delta to itself. If it adds 260, then you've gone too far. So I'm not going to put that in. So right now we have 1, 2, 3, 4, 5, 6, 7, 8. 8 ranges. That's what they are. They're actually the ranges. Because remember, this is our IP that's in inventory sitting there doing nothing. I'm going to copy that and I'm going to paste it here. Alright, so 0. That starts the range. Alright, that's this guy here. So I'm going to tab over. I'm going to paste it again. And I'm going to make this 31. You're like, what? Why 31? Watch. Because the next range starts at 32. And that ends with, come on you guys, you're catching the drift here? That ends with 63. Why? The delta is the beginning of the next range. So the, I'm sorry, the next IP in the sequence is 64. So, we get, this would be 95, 96, 127. You see how this is working out here? 59, 160, 191, 22, 223. And what's that equal to there? That's actually equal to 255 because the next number is 256, right? So literally, when you have a 0 through 31, that's literally 32 IP addresses. I mean, your fingers, you count your fingers, right? The fingers and the thumbs, you got 0 through 9, actually. Yeah, there's 10 to count on, there's 10. But really, 0 is the number, is a number, because it's a lack of number, but it is a number. Through 9, that's where you have 10 places. Anyway, they are our 8 ranges that we're looking for. So how many ranges how many the ranges or subnets, and that's what that equals to. There's 8. How many IPs per subnet? Well, usually the delta will tell you that right away, so it's 32. You're like, well, wait a minute. Hold it. The customer only wanted 20. Well, see, here's the problem with that. This is the way subnetting works with the number of bits. If I had taken away one more bit from it, And we take actually, let's do this. I'll show you right here because we say, well, how can we save IPs on this? We don't want to give them 12 free IPs, because well, you can't really charge for it. You got to charge them by the subnet if you're doing it that way. Because if we take that, and I take that to be a 1 over here, and then 8 zeros. See, look what happens here. What's the delta in this case? The delta in this case is the 16. You see that? So what do we have? 16 IPs. That's not enough for what the customer needs. The customer needs 20. So we're kind of, at an impasse here. So we have to go with the next bit, which is 32. It is what it is. There's not much we could do about it. You can't say, well, we'll give them a 16 and a slash something ridiculous like with 4 IPs or something. It doesn't work that way. Then we're going to need a router between them. Yeah, we're going to need a router between them. That's another thing. Between each of these subnets, if we're between this subnet and this subnet, for a computer to communicate between them, between these two, you need a router. You literally need a router to communicate between any one of these. Because the mask tells your computer that this is your subnet. Like if you're configured with an IP of a 192.168.50.23, whatever it is, it doesn't matter. And with the mask of 255.255.255.224 on your computer, it's going to know that your range is 0 through 31. It's going to know that. It knows 0 is the broadcast. It knows 31 is the, 0 is the ID for the block. 31 is the broadcast. So it knows the usable IPs are 1 through 30. And of course we could have the router here. So the router would be, in this case, 192.168.50. You can make the router any IP. We're just going to go by the number that everybody usually goes with, the .1. You can put the router as .18. It doesn't matter. It's up to you if you want to hide it. But anybody who's sleuth enough on as a black hat or white hat with cracking or hacking and such, they can figure it out. I mean, anybody with some knowledge of scanning software can figure it out. If I have a machine here, 192.168.50.40, 255.255.255.224, its subnet would probably more than likely be .31. I mean, you can make it anything you want. It's up to you. It doesn't matter. You want to know how your computer can figure out whether you are on a subnet or not? Well, what it does, it takes, like, say your computer is here. Your computer. Okay? That's your computer. This is the computer that you're trying to communicate to, okay? Or the destination. That's the destination host you're trying to connect to communicate to. We're going to assume that routers on both sides are working, so you have communication. What your machine does, it takes your IP. It takes your IP, and remember, everything's done at the binary level. 192.168. Easily, you can go to 192 and convert it to binary. All right, so 1 1 1 2 3 4 5 6. That's 8 bits there. 168. And like a decimal, 168. And I'll change it to binary. I'll just copy that. So, and 1 2 3 4 5 6 7 8. I'll just paste that in there. Dot 50 shouldn't be hard. 50. Hit binary, and you know what I just did? I used the keyboard. The F5 is actually hex. The F6 is decimal. The F7 is octet, and the F8 button is binary. So they are keyboard shortcuts. Now notice that the dot 50 here, there 50 here is only 1, 2, 3. There's 6 bits. Well, because that means the left 2 bits are zeros. So what I have to do is buffer it 0, 0, and then I'll paste the number in there. And 23, same deal here. If I go back to decimal, 23, hit binary, and the same deal there is 1, 2, 3, 4, 5. Remember, well, 23 is actually under 32, so you know it's going to be 5 bits anyway. Remember, we just learned that, right? Hope you didn't forget. 1, 2, 3, and paste. There you go. That's 192.168.50.23. Now, what the computer's going to do is because, let me go back to the mask here that we have. It's going to take its own mask and it's going to AND it. The ANDing process and the following two. Your computer will AND the following two, and that's what it's literally what it's called. What does it look for when it does that? It's like kind of like a subtraction. I mean, like a binary addition. If there's a 1 and a 1, it's 1. 1. If there's anything else, it's 0. 1, 0, 1, 0, 1, 0, 0, 0. You see that? I'm just adding the columns like, be math, like math, or at least well, you learned it here, 0, 0, 1, 1, 0, 0, 1, 0, dot, 0, 0, 0, 0, 0, 0, 0, 0. Oh, okay. I didn't realize it's going to be all zeros, but there you go. That's the result. Results of ANDing for your computer. Now what it does, it takes the destination IP right here, okay, and it will AND that IP address. We already know that 192.168.50 is this part, so I'm going to copy it, so I have to go through that again. Dot, and let's find out what dot 40 is. Go back to decimal, hit 40, hit binary, and there you go. Just right click copy. How many bits is that? 1, 2, 3, 4, 5, 6. 1, 2. So I'll make that. It's always got to be 8. Remember, the zeros go on the left. All right. Now we're going to take its own mask. You're saying, well, why is my computer going to use my mask? What about it using the destination host mask? Well, it doesn't know the destination host mask. How can it? All it knows is of its own world, its own subnet. Fish in a tank, it only knows of itself. Fish in a tank, if they want to get off their subnet, what do they do? They'll probably try to jump out. Well, it depends on the species of fish, of course. But anyway, it's another discussion. That's probably what you hear in the background, the pumps from our aquarium. Anyway, I will take that, copy that, and put it under it, because that's our my computer's mask. Same deal. Copy. This is my computer's mask. This is the destination host's IP. All right. So what's going to happen here, and we're going to AND that together too. And you're probably already seeing what's going to happen here. Let's try it. Let's put a line under there and let's get to work here. 1, 1, 0, 0, 0, 0, 0, 0. Watch me if I make a mistake. Correct me, please, if I'm wrong. 0, 1, 0, 1, 0, 0, 0. Oh, you can't correct me. Well, let's hope that I stick with the program, make sure I'm right. 0, 0, 1, 1, 0, 0, 1, 0, dot 0, 0, 1, 0, 0, 0, 0, 0. All right. And that's the results of ANDing for the destination host. You're going to say, everybody's probably looking at it right now, it's like, hey man, it's different. That's right, it is. It definitely is different. So in an ANDing process, if the two results are different, that says that the destination host is on another network. All right. If the two results were the same, the destination host is on the same network or same switch. That's what it comes down to. All right. So if it's on the same network, it will dump the packet right on the wire with a source and destination, to the destination host. However, if it belongs somewhere else, it sends the packet to the router or your gateway. You have to make sure your gateway is set properly. Remember, that's the reason why, and lets the gateway figure out where to find the other guy, the other network. That's how it works. That's how it works. Yeah, everything's all kibbles and bits, right? Kibbles and bits. Everything else is dog food. Now you can see that there's 8 hosts there. Usually, I remember back in the 90s, they used to say when it first comes out with Subnetting, not to use this. Because, oh no, you shouldn't use the .0 range. We use it. I mean, I think there was an RFC that came out and says, yeah, we could use it. Yeah. Anyway, let's talk about this a little more now. Okay. Let me take this a little further. Now we know that for the result for this customer that they needed 20 IPs. We could just give them this range. So we'll tell them for this customer, we'll say 20 IPs. The range will be this. Okay, this will be the mask. Or you could have probably just said, just for your paperwork, it's actually /27. How do I get 27? Let's go back to the mask, right? How many How many bits are there? There's 24, right? 8 times 3, plus the 3 here. That's 3, so that's actually /27. That's what we would say usually, and you would give them probably a DNS address or whatnot, or unless they're using their own, you can give them a DNS address so they can forward to. That's pretty much what it is, but we know that that's the range. So, all right, that said, let me go over this hex thing. This is the way you could relate actually hex to IPs. Hex actually literally is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Trying to do it too fast here. All right, that's all I'm going to go. 0. This is we're going to say this is decimal, and this is hex. All right, 0. That's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here's where it changes up, because remember, decimals 0 through 9, right? That's there's 10 in each block. Hex is 16, so it's really 0 through 15. But since there's no digits, numeric digits to represent 10, 11, 12, 13, 14, 15, we use letters A, B, C, D, E, F. So here it's A. B, C, D, E, F. What happens now? What happens with this guy? This goes to 10. It's 1, 0. This is 11, 12, 13, 14, 15, 16, 17, 18, 19, 2A. Alright, so you want to see what 2A looks like. You could say hex 2A. It'll allow, whoops, 2A, whoops, sorry, 2A. You could say decimal and, what did I do wrong? 26. So, what did I do wrong? 26 should be, hey, it's 1A. Oh, that's right. We're still in ones. Where did I get the 2 from? Ah, where did I get that from? We're still not done with the ones. There you go. See that? Sometimes I got to double check myself. 1C, 1D, 1E. Well, you get you get the idea. What we're going to do is we're going to translate that into IPs. Let's take a popular IP address from the internet. All right, I'm going to use let's look at Yahoo's. Why? You'll see why I'm doing this. I'm going to say NSLOOKUP. I'm going to say yahoo.com. You know what? I didn't want to do that. Okay, let me get out of there. I want to say ping www Yahoo. Okay, I want to get this IP right here. Why I'm going to do this? Well, you'll see in a minute. Get that out of the way. I'm going to change that to hex. All right, decimal 98, hex 62. So that's actually equal to 62. Next one is 139 in decimal. I'm going to change that to hex. It's actually equal to 8B. B 180 decimal, hex is B4, and 149 hex is 95. All right, what I'm going to do now is I'm going to combine these and take the spaces out. Whoops. All right. That's an interesting number, isn't it? So I'm going to actually translate that, put that in there as hex. First clear the screen, paste that. I'm going to translate that to decimal. Copy. So equals that. Okay. Remember, this is hex, and this is decimal. All right. You'll see what I'm going to do. Now I'm going to take French fries, FFs. Okay. Remember, Fs are 15. I'm going to take a full boat of fries. Listen to me. Remember, 255.255.255.0. If you look at that as or full bits for each octet, 255 is actually equal to 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? 4, 5, 6, 7, 8. That's actually if you translate that into easier way to do it is to take that and break it up to high order, low order. Remember we talked about that? If you add these up, it's really, if you add them up, it's 16, I'm sorry. It's 8421. Okay, and space 8421. That's how the, just to break that up just to show you. All right, that's how that works. If you, so these are all ones in the low and the high order of the byte. That's 8, that's 12, 13, 14, that's 15. So that's actually equal to 15 decimal. 15 decimal is F in hex. So that actually, I didn't want that to advance to the next line. So that would have been 15 as well. So that's actually equal to F, or so it's FF. So if I have FF.FF.FF.FF, remember I'm looking for all high order here. We used to call them French fries, cheeseburger, CB. You know, that's when we were in the, you know, working with mainframes. Anyway, I'm going to take the FFs. All right, that's a full high values is what we call it, because it's got everything. Everything's full. Take the hex, paste that. And I'm going to get the decimal out of it. Look at that number there. Copy. And remember this decimal here? I'm going to take a FF. And I'm going to add those two together. Alright. And then I'm going to say plus, paste, equal. Copy. Equals that number there. I am going to take that number there and whoops, I should have put it on your screen here. Notice that I took that number there, 594.82.8901. I pinged it. Look at the IP address. It's actually one below here. You see that? How'd that get lost? It got lost in the binary translation. So what we could say is I could take that number and just add the 1. That actually gives me Yahoo site. Yahoo site. Now watch. If I open up a fresh browser here. And I'll say http:// the number here. Is that the number that we pinged? 140. 140. I'm going to put that 190. It's that 97. Remember, I had to add one to it. See how it translated? Now see, it doesn't like it because it's behind big IP or some other kind of F5 or some other kind of like load balancer, which is actually redirecting internally. So that's why it doesn't like it. I mean, if I go in www.yahoo, it'll actually resolve that and connect to it, but it doesn't like the IP. Anyway, but you can see how that works. Pretty interesting, huh? Now let me take this one other step here. You have another problem. Okay, let me think of a good one here. You have a call center. You have multiple call centers. You have 40 call centers. The company's growing, and that will increase. Possibly add 15 more centers. Each center has about 750 users. I mean IPs, servers, everything else. What will the range be? And how many possible max subnets can I get out of it? All right, what do you start here? What's the best way to start? you're got to look at the networks here. That's what you're looking at. Yeah, you're going to look at the IP addresses too, but we're going to look more at the networks here. Remember, networks are all the ones here. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Whoops. Let's just go. Let's just write down. Okay, you look at this here. I could. How many? What's the maximum number of IPs that can fit in here? Well, we already established that 1, 2, 3, 4, 5, 6, 7, 8 is 255. Will that handle the 750 users? No way. So how do we handle the 750 users? Let's look at that first. I'm going to go back up here and type in 750. All right, I'm going to go back to binary. Look at, there's the number. So I'm going to say 750 equals that in binary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're like, oh, how the heck do I put 10 bits, zeros in there, because the thing only goes to 8, the last octet? That's a good question. That's an excellent question. So what we do is we're going to keep going. We just walk right past it. That's it. That's what we'll do. So now the mask becomes 255.255.something.0. What's that something? I don't know. Let's put it in a contrapulator. Listen to me. Let's put it in a calculator. All right. Well, 1111100. Right. Let's change it to decimal. It's 124. Check that out. Did I do that right? No, see, I didn't do that right. That number didn't look right at all. I didn't have enough bits here. That's why I like to break it out. That's why I like to space it out sometimes. I can see it better, that I know that I have the right group of 8. Okay, let's try this again. Binary. I looked at that. That didn't look right at all. 1, 2, 3, 4, 5, 6, and 0, 0, 7, 8. Right? Let's go to decimal 252. That's more like it. So the X here is actually equal to 255.255.252.0. You're like, wow. What's the delta here, ladies and gentlemen? Huh? What is the delta? The delta is, we don't care now. We're way past this. Now we're into this octet here. Okay, the delta here is the 3rd bit. Remember what the 3rd bit is here now. Let's take a look. Let's go all the way back up here, wherever I wrote that, broke it out. Where did I put that? Doesn't matter. All right here. Okay, delta. Remember, do this. All right. Let me take that. In this case, the delta is the 3rd bit, right? So it's really 1, 2, 3. The delta is 4. Yep, the delta is 4. So the delta will be 4. So what's that mean? So that means it's 4.0. All right, that's your starting point. Well, really, it's going to be 4.0. That's your starting point. Then it's going to go to 4. Actually, let me just write out. Let me play out the deltas. Plus 4 is 8.0, because I'm using that would be the 4 would be here. The IP address 4. This will be the .0. You'll see what happens in a minute. 12.0, 16.0, 20.0. I'm not going to write them all out. 24.0. You can see that there's going to be quite a number of them. All right. First of all, I should have asked is how many IPs will this handle here? Because we have to cover that 750 users, right? Well, let's see. There's 10 IPs there. So, or 10 bits, I mean, 10 bits. So I'll go up here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decimal 1023. Yeah, so that equals 10 bits equals 1024. Really, is what it is. 24, which will handle the 750 users. I forgot to mention that. Yeah, it's a really important step, right? Yeah, that's what the whole thing is geared on, taking care of these people, make sure each call center is fulfilled. We want 40 call centers, but anyway. Right now, so 4.0, that's going to go to 7.255. So say, you see that range there? So if I have something in stock here, maybe I'm going to say we have 0.0 in stock. That's our in inventory, and we have already some of it used, but we haven't used some of these ranges here. So let's take this here and expand it. 10.10.4, 10.10.7.255. So back home, 10.10.80, 10.10. Guess what it's going to be? 11.255. You see the pattern emerging? Now, will this fit with the 40 here? I'm not going to copy these out here, but 1, 2, 3, 4, 5, 6. We already have 6 there, and if we keep going, well, this will tell you how many networks there are right here. How many bits are there? Remember, in this octet, there's 6 bits. 6 bits. 1, 2, 3, 4, 5, 6 decimal. It actually will handle 63. Delta's 4. So that equals to 1024 per subnet, and then that's actually equal to 6 bits for the networks equals 64 networks. Always remember to add the 1 there, because 0 is 63. I say here 10 bits for hosts. So there you go. That's actually the answer right there. The trick I showed you back here with this I learned this quite a number of years ago when spammers were first coming around trying to do their thing with email and stuff. They would try to get you to click on something, and they're trying to hide their IPs and their names, their domain names. This way they don't get caught. I mean, it's really ridiculous because they could easily get caught. So I figured out what they were doing because I saw that coming through emails like, oh, click here for blah, 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 http://594. I'm like looking at it like, what? How the, and then I sat there and I back engineered it, or reversed engineered it. That's how I figured it out. Anyway, that's how you can manipulate, in this case, how many hosts that we need. In this case, really the question was how many can we, based on the call centers, and of course we have to take the host into consideration. First, we came up with an IP with a subnet that actually gave us the ability to support the 750 users. Then from there, the number of subnets just fell in place to handle the call centers. If not, we would have had to probably extend the subnet into the next octet. I was going to go into class A, B, and C, but that would be for another day. Right now, we were working with private IPs. Private IPs have a specific range, but this have ranges that have been what we call black hole routers, that they're ignored on the internet. But anyway, this is basically how you subnet. I hope you learned something. If you want to learn a little bit more about the about subnetting from my site, there it is right there. Just look up my name, Acefekay, ACEFEKAY, and space subnetting, and you'll find it really quickly. Okay, here's a quick Bing, Acefekay subnetting. And oh my God, look at that. Anyway, thank you very much for your time, and please enjoy your day. Be safe. Thanks.